All right, here's a question where we are asked to determine the empirical formula for a compound. So it gives us a bunch of information, and it gives us a bit of extra information here at the end. It says the approximate molar mass of the compound is 90 grams. And so from the information given, what we're wanting in the end is to have, we've got carbon, hydrogen, and oxygen, and we want to know what ratio all of those things come in. So this might be a 1, a 4, a 3 or something. Probably is not that, but these will be numbers. That's what we're wanting to get out at the end. So if they ever give us as a percentage, it's percentage probably easier than just giving us grams of something. Maybe not easier, but I guess in some questions. Anyway, when it gives a percentage, what we can do is, if it's a percentage, all we're looking at is a ratio between compounds or between elements. So if they give us a percentage, we can say, well, okay, if that's a percent, why don't we say I've got a sample of 100 grams of this compound. So if 40% is carbon, that means I have 40 grams of carbon. Okay, it also means I've got 6.71 grams of hydrogen. And I have 53.29 grams of oxygen. And now what I need to do from here is to determine how many moles there is, and then look at the ratio between them. Okay, so to find out moles, multiply this by a conversion factor. 1 mole of carbon weighs in at 12.01 grams. If you multiply and divide that, I think it comes about to 3.33 moles, something like that. Okay, next one, hydrogen, 6.71. 1 mole of hydrogen weighs in at 1.01 grams. Notice I'm using 1.01 and not like hydrogen by itself is diatomic. If it was diatomic, I'd be using 2.02. That's if it's hydrogen by itself. But this compound, hydrogen, is hooked up with something else, so I use its normal molar mass or atomic mass. Okay, when I divide those, I think that comes out to about 6.66 moles, or close to that. And then oxygen, same thing. 1 mole of oxygen weighs 16.00 grams. The grams on all of these cancel like we usually do. And that, when you divide that, comes out to about 3.33 moles too. Nice that these numbers all came sort of together there. So then what we do is, like in a normal question, we will take each one of these and divide it by the smallest one. So let's do carbon, and just to see what its ratio would be. So carbon was 3.33. The smallest number of all of them is actually also 3.33. So the ratio for carbons compared to hydrogen and oxygen would be 1. So I have 1 carbon for every whatever the hydrogen and oxygens are. Okay, hydrogen is 6.66. Divide that by the smallest one, that comes out to 2. So every 1 carbon, I got 2 hydrogens. You can probably already see what the oxygens are going to be. 1. So when I was looking at that compound up here, knowing how many carbons, hydrogen, and oxygens there were, it looks like there's going to be 1 carbon, 2 for every 2 hydrogens, and with that 1 oxygen. So this would be, I could call it my empirical formula, my base. Why don't we call that? Let's call this the base empirical formula. Whoops, empirical formula. So 1 carbon, 2 hydrogen, 1 oxygen. Now, additionally in this question, they also told us that the molar mass approximate of this compound is 90 grams. So let's take a look at this and see what that would be. So if I had 1 carbon, that's at 12, there's 1 carbon, weighs in at 1201, so that's 12.01 total. 2 hydrogens each hydrogen is 101, and so altogether that's 202. And then one oxygen weighs in at 16. 1 times 16 is 16 together. So when I add that up, what's that? 2830.03 grams per mole. So just our basic compound here, our basic ratio is 30.03. But they say that the molar mass of the compound is 90 grams per mole. So if I take a look at the comparison, how do I get from 30 up to 90? Well, 30 times probably 3. So if I multiply this molar mass by 3, I can get 90. So then what I need to do is just to take each one of these numbers, and if I want to triple this number, I just have to triple each of these. So I'd need 1 times 3, 2 times 3, 1 times 3 is 3. So the empirical formula, sort of the finished one, for this compound, given all the information, I'd have 3 carbons, I'd have 6 hydrogens, and I'd have 3 oxygens. Okay, hopefully that helps you with that type of question.